All right, I think we can get started here. Welcome, everyone. Thank you so much for joining us this evening for our Meet the Department series. This evening, we have our Marine and Environmental Science Department here. And when I say Meet the Department, I think half of the department is here with us today. So you are going to have a great opportunity to hear from so many different faculty members as well as students who have given us their time this evening. So we're excited about that. To begin with, as always, if this is, if you've joined us multiple times, we're following the same format. There is a chat feature on the bottom of your page, and that's where you can submit questions at any point in time during today's session. We will get to as many questions as possible towards the end of the presentation. And we will also be posting contact information. So if you have any additional follow-up questions that are specific to your interest or concerns, please do reach out directly to some of our presenters from the panel today. All right, without further ado, I am going to turn this over to the chair of the Marine and Environmental Science Department, Jeff Trussell. Dr. Trussell, how are you this evening?
Good, thanks so much, Lauren, and welcome everybody to this virtual session. I'm sorry, I hope you're all doing well. Very unique times that we've been living in for the past year or so. And it's unfortunate, obviously, that we can't meet you all in person, but hopefully you can get a good sense of what we are about as an academic department and as a community as you continue to think about where you'd like to continue your academic studies. So, in a very general sense, our department is focused on developing a really robust, in-depth understanding of the various processes that affect both the Earth and the oceans. And a critical feature of our approach is really integrating human society into that study, because we are fundamentally dependent on the natural ecosystems of our planet and the ecosystem services that those systems deliver to us. Now, in the past, we've done things very differently as a society. The first thing that scientists try to do is get as far away from humanity as possible to understand how nature works in its undisturbed state. And the reality is that that approach is antiquated now. Half of the world's population and associated economic activity occurs along the world's coastlines. And there's virtually no part of the planet that hasn't been impacted by human activities. So this collision between humanity and nature creates significant challenges that we must address in an environmentally and sustainable way, economically sustainable way. And so in the following slides, we're going to highlight some of the challenges that we think serve as focal points for a lot of the coursework that we're doing in our department, as well as a lot of the research thrusts that are motivating the research mission of our department. So just to give you a quick overview, one of these challenges is pollution. And for many of you, I suspect because you want to major in science, you've heard a lot of these things already. But things like pollution in the form of enhanced nutrient delivery to coastal watersheds is creating real challenges. And this has been a longstanding problem, but it's actually accelerating. In fact, a lot of the nutrients that are delivered into coastal systems create a process called eutrophication, which leads to exponential algal growth. And as a result, eventually that algal growth decomposes and dies. And in the process, it chews up oxygen and creates dead zones. And many of you probably have heard about the dead zones that occur in Gulf of Mexico, but don't fully appreciate that most of the nutrients that are creating those dead zones are coming from Iowa. So this idea of how interconnected systems are is a really important aspect of how we approach things. More recently, the problem of plastic pollution, especially microplastics, is becoming a really urgent concern because they're becoming incorporated into natural food webs with important consequences for higher trophic levels, including the fish that we rely on for food. And even more vexingly, a lot of these microplastics end up being what we call little cyanide pills, because a lot of compounds that are really bad for us tend to be hydrophobic. That means they don't like the water. And so they concentrate in these microplastics. And it's a new contemporary vehicle of biomagnification that characterized a lot of the chemical pollution concerns back in the 1970s. Overfishing and unsustainable fish farming. You probably don't realize that right now, about 25% of the world's population relies on the world's oceans for its primary source of protein. This demand is only going to grow as our population approaches 11 billion people by 2100. And yet 70% of the world's fisheries are either overexploited or commercially extinct. So this has created real concerns about global food supply and the long-term commercial viability of fisheries. Now, we're implementing fish farms around the world at a rapid pace, but these generate their own problems, including magnifying coastal pollution, contaminating natural fish stocks by farm genotypes, and spreading of marine disease. So, these fish farms are not the panacea that we all once thought they were. And so we really need to think carefully about how to implement them in a sustainable way. Invasive species. With globalization, the world's economies and its species are becoming increasingly connected. Now, the term invasive species refers to the transport of the species, typically in the ballast water of cargo ships, from one region to another that otherwise would not have occurred without human assistance. This transport of invasive species can become quite disruptive to recipient ecosystems. For example, in the Great Lakes, the invasive zebra mussel has impaired the operation of power plants by clogging intake lines. And it's also undermined the stability of the food webs in the Great Lakes because these invasive mussels are prodigious consumers of phytoplankton, which means that they're taking food away from a lot of the native lake species that rely on phytoplankton for their sustenance. Climate change. Now, at this point, I'm quite confident that all of you realize how significant and existential this challenge is. Since 1800, the oceans have risen about 8 inches in sea level, but the worst case emission scenarios project an additional rise of 6 feet by 2100. And unfortunately, with new studies and better technology and better models, these projections are being revised constantly, and they just keep getting worse. So sea level rise coupled with intensifying coastal storms and hurricanes is going to continue to pose significant threats to human life and coastal infrastructure. So in a nutshell, although we must continue to mitigate how we deal with climate change or mitigate inputs of carbon dioxide into the atmosphere, we also need to accelerate what it's going to take for us to adapt to changing sea level and changing climate. And what is that going to mean for coastal cities, coastal communities, and coastal ecosystems? So I suspect that a lot of what I've said to you is you're all getting excited about going to school, and you're listening to a guy rant about how significant the environmental challenges are that are out there. But the important thing to realize is that our approach and the students that are studying with us are leading the way in creating knowledge that really promotes environmental sustainability. And when I say this, it's really important to understand that it's really trying to hybridize benefits to human society as well as environmental health. We're not talking about just preserving and protecting everything, because that really is not the path forward. We need to find ways for humans in the natural environment to live in harmony with one another. So we have folks that are really working on innovative solutions to deal with some of the challenges that I've mentioned. One great example is Stephen Cyphers. He and his students are looking at the effectiveness of different shoreline protection approaches. Now, the traditional approach has been, let's just armor shorelines with seawalls. And in some cases, that's certainly the best approach. But there's growing evidence reveals that green or hybrid gray-green approaches can be even more effective in protecting human communities from storm surge and flooding. In fact, recent estimates that were stimulated by the impacts of Hurricane Sandy indicate that for every $1 invested in green shorelines can save up to about $6 in reduced property losses. We have other folks within our department that I'm sure you'll get a little bit more exposure to as we continue our discussion, but we have folks like Brian Helmuth, who is working on how marine species respond to climate change and how our understanding of those responses can inform climate policy. We have Dr. Mark Patterson, who has been working on better parameterizing the microplastics problem in the world oceans, which includes a new invented microplastic sampler, which was actually invented by a Northeastern undergraduate, Ethan Edson. And that invention was funded by a grant from the Schmidt Foundation of Google. And now Ethan's running his own company up in Canada. So Ethan's a great example of how our students approach a problem, come up with a great solution, and then end up having a career that's devoted to it. We have Dr. Grabowski, who's working very closly with fishermen and government agencies to figure out ways to come up with more equitable fishing quotas so that fishing communities like Gloucester, Massachusetts, for example, don't suffer the significant emotional as well as economic turmoil that they have been suffering as a result of the quotas that have been imposed on them. And do we have anyone else? I talked about Stephen. Oh, and then finally, Dr. Randall Hughes, who is really marrying, is a perfect example of marrying the virtues of fundamental research with translational research. So Randall is someone who led the way in discovering that increased genetic diversity, so increased biodiversity in the form of increased genetic variation, can actually enhance the functioning of seagrass ecosystems. And it turns out that that same philosophy or same approach can also enhance the effectiveness of seagrass and salt marsh restorations. Think of it like an investment portfolio. If you have all of your stocks in one sector, you're going to be vulnerable to big upswings and downswings in the market. But by having a diverse set of genotypes or a diverse set of stocks in your portfolio, you reduce your risk to those amplitude events and enhance your chances of persistence. So hopefully that gives you folks a good view of the types of people that we've brought together in our department. And really what we're focused about are cultivating the skills in you that help you arrive at these solutions to the various challenges that our planet is facing. And so we've got 4 distinct majors: ecology and evolutionary biology, marine biology, both of which, by the way, can be feeders into pre-med if you so desire, environmental and sustainability sciences, which is a completely revamped curriculum that's much more in alignment with a lot of what I've talked about today, and finally, our environmental studies major. And so while a lot of these majors have their own independent strengths, they all share the real value of a multidisciplinary approach to problem solving. And there's obviously lots of cross synergies among these majors, so that you're not, if you're an environmental studies major, for example, it's not like you're not going to spend some time learning about ecology and evolution and vice versa. So the conceptual linkages between these majors really enhance the academic training of students that come to Northeastern and live in our department. And they really prepare them with a skill set, particularly with respect to quantitative skills, analytical skills, that are going to position you regardless of what job you want to pursue after graduation. So I appreciate you listening. I know that's a lot of information in a relatively short amount of time. I'm now going to turn it over to Becky Rosengaues, who will talk about our ecology and evolutionary biology major. Thanks, Becky.
Great. Thanks, Jeff. Hopefully everyone can hear me. Again, my name is Becky Rosengaues, and I am one of the faculty advisors for this amazing major, ecology and evolutionary biology. And basically what I would like to say here is that if you love being surrounded by nature, if you love understanding the dynamics between the living and the non-living, this is really the major for you. I think that this major allows you to look at very different themes or topics, including population, community, and ecosystem ecology, as well as evolutionary ecology, biology, as well conservation biology, population genetics, ecological and evolutionary genomics. And so the whole point here of this major is that it's designed so that you do not only become a naturalist, but actually you become a scientist. We want you to have a good foundation, an excellent foundation as a scientist, so that it will anchor you with all the theoretical and all the practical aspects of what it means to be an ecologist or an evolutionary biologist. So as a scientist, you will be learning biostatistics, and you will be learning conservation science, and you'll have to do chemistry and physics, because these are essential parts of what a scientist is all about, as well as, you know, doing genomics. And again, more importantly, besides all these different courses, what's important is that you will become, or you will get more skills of how to be a problem solver. You'll be able to figure out experimental design that allows you to tackle questions that will hopefully give you robust data that you can then use for, you know, improving the world, in other words. You will develop critical thinking, as again, Jeff mentioned some of these very important traits. And this critical thinking will be important for looking at complex ecological and evolutionary biodiversity questions and issues that, of course, are so important right now with respect to global warming and all the issues that Jeff already spoke about regarding the present state of the world. So with respect to jobs, I think that it's also important to talk about the jobs that you can expect to land once you finish this major. It really depends on your interest. You can do research, as us, most of us are doing research in academia, and we're teaching, and we're being at the university level while we're still doing research in this university. But in addition, if you like teaching and you don't want to be in academia, you can do high school teaching, you can do elementary school teaching, and bring again ecological and evolutionary teachings into these young generations. In addition, you could be, work for governmental agencies such as the USDA or wildlife, fish and wildlife, again, governmental groups that will be able to project and provide information about how to translate what you're doing into applications for humanity. In addition, you can do policy as well with the degree that you happen to have right now with ecology and evolutionary biology. So I think that you will be a very well-rounded student. Again, as Jeff mentioned, if you take this major, you can also decide to end up as a medical doctor or vet school. You would have to take a few little extra courses here and there, but you would be actually fulfilling many of the requirements for medical school as well. And so hopefully I've given you a very fast overview of what this major is all about and what you could look forward to doing with your degree once you leave the university. So having said that, I would like to then pass this along and introduce to you to Dr. Sam Munoz, who will be talking, I think, about environmental science and environmental studies. And I'm around if you want to talk about this. Please feel free to just send me an email. I think the emails are at the end of this lecture, or shoot me an email, a chat quickly here, and I'll be very happy to talk to you later on as well. Thank you.
Thanks, Becky. So again, I'm Sam Munoz. I'm an assistant professor in the department here. And I get to talk to you about two of our programs. The first one is our sort of newly revamped environmental and sustainability science major. So this is a Bachelor of Science in Environmental Sustainability Science, and it is designed for students who want to use scientific knowledge, scientific background to solve some of these environmental problems that Jeff was talking about. And again, we really emphasize this multidisciplinary perspective. And so this program sort of as a big picture trains you to investigate, develop, and communicate solutions to environmental issues. And again, you're going to integrate knowledge across the natural and social sciences. And so in your first year, year and a half, you take this sort of core set of courses in earth and environmental science. That's a class that I teach, first year of science, ecology, data analysis, communication, and math. And then after that, in sort of your second, third, and fourth year, you select an area of expertise or focus. That's what you go on to focus on. And so there are 4 of these areas to focus on. I think they're called concentrations. So the first one is called environment and society. So this is sort of the most on the, let's say, more on the social science side of things. This is where students, you're going to study human and natural systems together and to think through solutions for communities that are affected by environmental change. The next one is called sustainable planning and development. This is where you're going to leverage this sort of scientific framework to think through, to study how food, water, and energy can promote sustainable solutions to environmental problems. The next one is called conservation, restoration, and management. This is where students examine how ecological and evolutionary processes affect how we conserve, restore, and manage ecosystems. And then last but not least, earth, oceans, and environmental change. This is where students study the physical, geologic, and geologic processes that shape the Earth system and that really underlie a lot of these environmental processes and environmental issues that we deal with. So all of these concentrations let students really deepen their knowledge of environmental science from these different sort of social and physical perspectives. And then in your final year, in your fourth year, final year, I should say, all these students in these different concentrations, you started out together as this core group, you go off and develop your expertise on these different concentrations, then you come back at the end, you take a capstone course together where you work in teams to address these pressing environmental problems. But again, you're coming at it from these different perspectives and kind of mimicking how it would be in the workplace where everybody has their own specialization. You work in teams to solve these complex problems. So a lot of the work that our students do and our faculty do really sit at this interface between climate change and environmental science. So we have a nice video here of Professor Brian Helmuth talking about some of the work that he does. Let's watch that. Jen, there's no audio.
Bandwidth.
My research group studies the impacts of climate change and other stressors on coastal ecosystems. We mostly work in the rocky intertidal zone, so that kind of narrow margin at the edge of every ocean between the low and the high tide lines. We try to understand where climate change impacts are most likely to happen so we can do something about it. We use a wide range of techniques. We'll start with weather data or remote sensing data. We'll try to then translate that into how the organism sees it. So we'll use a series of computer models or physiological measurements in the lab, in the field, and ask how is climate change likely to drive the physiology of an organism. The ultimate goal of that then is to take it back out and say, what larger scale changes will we see in coastal ecosystems? What impacts might we see on fisheries? What impacts might we see on something that's preventing erosion? And if we understand those impacts, how can we prevent some of the worst effects of climate change?
Apologies for the bandwidth issues.
So yeah, some of those shots were from the Marine Science Center, which is our campus that's out in Nahant, where a lot of us have labs and offices, including me. I have my lab out there. It's a really beautiful place, and a lot of undergraduate students do co-ops and research out there, which is an awesome opportunity. So next, I get to talk to you also about our environmental studies major. So this is a major that we've also recently revamped, and this is really about students that are really broadly interested in developing this sort of what we think of as a transdisciplinary approach, something that transcends traditional disciplinary boundaries. And they really want to do this for environmental problem solving. And a lot of the strength of this program is that we're building on some of the other strengths that exist within the university. So most of these programs sort of are coupled with other departments in the university. So they start in this program, the students start with courses that cover scientific foundations of human dimensions of environmental problems with an emphasis on food, water, and energy. Then students focus in on one of these 5 concentrations. So the first one that's listed up here, environmental and human health. This is where students work with both environmental and public health leaders to focus on creating healthy human and ecological communities. The next one is called environmental ethics and social justice. This is where students learn to build a more just and equitable approach to solving environmental challenges. The next one is called environmental law, governance, and management. This is designed to prepare students for entry into law school, and particularly environmental law, and builds an understanding of the legal and policy structures that underlie the environmental challenges that we face. We also partnered with the design school to develop a concentration on visualization and communication of environmental problems and solutions. In this concentration, students focus on building skills to create, design, and communicate solutions to environmental challenges through the combination of art, data, and storytelling. And last but not least, we have also partnered with the business school to develop a concentration called the Green Economy, Business, Entrepreneurship, and Environmental Sustainability. And in this one, this is where students build their business skills and develop entrepreneurial strategies to solve environmental challenges. So together, these programs that I've talked about in environmental and sustainability science, as well as the ones in environmental studies, they give our students a whole lot of entry points into lots of different environmental careers, whatever they want. And then, like Jeff emphasized in the beginning, you know, there's a lot of overlap between these different programs and the different concentrations within them. And so we don't want to create these really sort of siloed students. We want to create people that are open and multidisciplinary and able to tackle things from lots of perspectives. So next, let's listen to John Grabowski, another professor in our department, whose research and teaching exemplifies this complementary interdisciplinary path.
I've worked collaboratively with lobster fishermen, with groundfish fishermen, oyster fishermen, all kinds of fishers around the country, and even some elsewhere. There's huge fishery as a natural bridge, and ecosystem service valuation is a natural bridge between the disciplines of ecology and economics and also public policy. And so we can use that to inform better decision making around habitat restoration and protection. For instance, you know, if we know that this ecosystem services that a habitat like a seagrass or a salt marsh or an oyster reef provides, we can use that and weigh that against activities that would damage that habitat, like dredging for a harbor or extracting the oysters themselves as a resource from a reef. A recreational fisher goes and visits an oyster reef. How much do they spend to go visit it? So if we can quantify the average price they're willing to pay and the number of visits that will occur on a created reef, we can actually assign a value to that recreational fishery in terms of their trip costs that they would spend.
All right. And last but not least, I'll just briefly mention some of the many, many jobs that you can go into with a degree in environmental science or studies. So, I mean, these degrees give you this solid background in environmental science or studies, and that background is really fundamental to all kinds of potential jobs and careers in both the public and private sectors. And some of those are listed here. You know, we could talk about this forever. But graduates of our environmental studies program, they could go on to work in things like environmental law, urban or regional planning, environmental consulting, environmental education, just as a few examples. On the more environmental science side, graduates could go on to work in water resources management or environmental analytics, conservation management, soil and agricultural sciences, and many more. You know, ultimately, it's these environmental processes underlie so many aspects of our modern lives, and so expertise in environmental science and studies is sought after in all kinds of careers and fields. Mm-hmm. So last but not least, or I should stop saying last but not least, I will next pass you off onto Tara Duffy, who will talk to you about our major in marine biology.
Thank you, Sam.
Hi, good evening, everyone. I'm excited to talk about our marine biology major, in part because the oceans are basically the last unexplored habitat on the planet. It's truly the Earth's last frontier. So the department's Marine Science Center Coastal Sustainability Institute, located on a 20-acre peninsula just north of Boston, provides a tremendous access to marine systems that you can get out and explore, making Northeastern a really great place to be a marine biology student, both to utilize the resources on campus, but also to utilize our Marine Science Center Coastal Sustainability Institute. So the marine biology major provides students with a strong foundation in biological and marine sciences. Typically, as many of our majors do, the first 2 years, students are completing foundational science courses in biology, chemistry, physics, and mathematics, and then get to delve in much deeper to gain that depth of knowledge. So our students can fulfill their upper level marine biology requirements either on campus or during our year-long 3 Cs program, which I'll talk about in a moment. But that program is widely viewed as the premier experiential educational program in marine science for undergrads and both master's students, including +1 students. It's important to note that while this major focuses on marine science, the breadth of knowledge and skills acquired by marine biology students does make them very well prepared for tackling environmental problems, regardless of the ecosystem that they're interested in working in ultimately. So next I'll talk about our 3 Cs program. The 3Cs program provides students the opportunity to spend a year studying marine biology in 3 different marine environments. So students spend a bit of time in New England at the Northeastern Marine Science Center, where they get to interact with many of the researchers working on these issues that we've been talking about. And then they split a semester between 2 locations, the Pacific Northwest at Friday Harbor Laboratories located in the San Juan Islands in Washington, and in the Caribbean at the Smithsonian Tropical Research Institute in Panama. This is a unique opportunity for students to live and work in the environment that they are studying and to explore 3 very unique and exciting environments. 3Cs is really a unique program, and no other college experience in the science offers the opportunity to learn in 3 diverse ecosystem locations in such depth, and enroll in a wide variety of marine biology courses, as does 3Cs. So the alumni of our program have gained admission to the best graduate programs and are now leaders in their field, including our very own Professor Steve Vollmer, who is a coral biologist, Professor Catherine Matassa, who is a faculty member at University of Connecticut, and many other faculty. And it also prepares students to work actively in fields like conservation and restoration, fisheries and aquaculture, and management of marine systems. And I'm happy to answer any questions about the 3Cs program. We also have what are called combined majors. So these combined majors are available for students who prefer a more interdisciplinary approach, even more so than what is offered within the department. They are unique blended programs that are designed to allow students to explore multiple fields, all within one integrated academic plan. The academic experience in a combined major occurs typically across 2 colleges, so students can take advantage of the resources that are offered by both colleges. Although upon graduation, 1 degree will be conferred by 1 academic college, and you can see the sorted combined majors that are offered with our department. And then we also offer some exciting +1 opportunities. So these are accelerated bachelor's and master's degree programs. These +1 programs allow students the possibility of attaining a master's degree in as little as a single additional year beyond their undergraduate career by applying graduate credit to some courses taken while in undergraduate. And that's typically 16 credits. In our department, you can combine most of our undergraduate majors with our master's degree programs in both marine biology and in environmental science and policy. Thus, if you're interested in marine policy, for example, you could get a bachelor's degree in marine science, and then with an additional year of study, you could get a master's in environmental science and policy, which makes this a really exciting opportunity. If you come to Northeastern, we do have the program that is right for you. You can see the flexibility and the variability in what we offer. But more importantly, we have amazing mentors here who understand how important it is to train you all, because you are all the next generation of problem solvers who are going to make the world a better place, truly. So let's listen to a brief video by Dr. Amy Muller. Dr. Muller holds a joint appointment in the College of Science, and College of Engineering.
I'm a professor of civil and environmental engineering and marine and environmental science at Northeastern University in Boston. I work at the confluence of engineering and science to develop the technologies we need to answer important questions about human influence on the environment and how we can mitigate that. The technologies I work on gather more data so we can have rationalized management systems of things like fisheries and other natural resources, as well as optimized processes so we reduce the effluent into the environment and our pollution footprint. I use my research as a way both to answer questions that help society, but also as a tool for mentoring students for the next generation. Over the past 5 years, I've been able to mentor more than 15 students in 6 different departments at 4 different universities. And I think this is a critical component of being a leader in the field, is training the next generation of science and engineers who will take this up as their charge as well.
All right, so next I'll introduce Emily Miller. Emily is the Marine and Environmental Science Dedicated Co-op Coordinator.
Thank you, Tara. Hi, everyone. So I'm Emily Miller. I'm the Co-op Coordinator for the Marine and Environmental Sciences program. So Northeastern's Cooperative Education Program, also known as Co-op, It's an educational model that allows you as a student to alternate periods of academic study with 6-month periods of full-time employment related to your major and your interests. So this combination of academic study and full-time employment provides you with an integrated learning experience and enhances both your in-class studies and your future career development. Completing a co-op is one way for students in the College of Science and in the Marine Environmental Sciences program to fulfill the NU Path experiential learning education requirement for graduation. And students who intend to go on co-op, you're assigned a pattern, and it's either the spring semester, so we say that's January to June, or it's the fall semester, which we say is July to December. And co-op is optional, but we highly recommend it. And about 90% of our undergraduate students participate in the program. Co-op allows you as a student to gain really valuable hands-on work experience. You'll have the opportunity to develop new interests, leadership skills. You have the opportunity to create a professional network, and that will in turn enhance your classroom experience. So through the co-op search process and by working full-time for 6 months, you learn as a student about different career options that are available to you. And it's a really, really great way to explore what you like and what you don't like before you graduate. So as a student, you can complete 1, 2, or 3 co-op semesters, and that allows you to gain up to 18 months of professional experience. Northeastern students have the opportunity to apply and work for world-renowned companies and institutions, and that allows you as a student to be even more competitive when you graduate, whether you're applying for full-time opportunities when you graduate or grad school opportunities. And in fact, 93% of our grads are employed full-time or enrolled in grad school within 9 months of graduation. 50% of our students receive a job offer from their co-op employer upon graduation, and 89% of grads are doing full-time work in a field related to their major. Northeastern's co-op program is one of the largest and the most successful in the world. We partner with more than 3,000 employers across the US, and we have opportunities domestically and abroad. We have opportunities available in currently 136 countries around the world and on every continent, including Antarctica. And I provided some employers that we work with pretty consistently on the slide, so you can see some examples. In the Marine Environmental Sciences program, students complete co-ops at private and nonprofit companies. So we work really closely with New England Aquarium, Environmental Defense Fund, Indigo Agriculture, Woods Hole Oceanographic Institution, various farms and veterinary clinics. And we also work with different government and state agencies such as the Massachusetts Clean Energy Center, Mass DOT, Department of Transportation, and City of Boston and State of Massachusetts. There are also opportunities for students to go to co-op with staff and faculty at Northeastern's Marine Science Center, Coastal Sustainability Institute, and Ocean Genome Legacy in the Nahant. And the university has a large number of existing positions that faculty have cultivated to best meet the needs of our students. But as a student, you also have the opportunity to self-develop your own co-op position in your field and area of interest if you'd like to. So as an undergraduate student, you're eligible to do co-op after completing 3 academic semesters and after you've been assigned a co-op cycle. So I mentioned that before, that's called your pattern of attendance. That's either January to June or July to December. Students are provided dedicated support throughout the experience. So each student is assigned a co-op coordinator who helps the students prepare for the process. You also have to enroll in a professional development for co-op course. Through this course, you learn important and necessary skills about job searching, how to self-develop, how to write a cover letter, how to do a resume, a professional resume, lots of interviewing, and different networking techniques, professional behaviors, and work ethics are all the different things that we cover. So this slide shows a review of a few more co-op logistics. So although students are maintaining their full-time student status on co-op, they don't have to pay tuition while on co-op. And as I mentioned before, students are alternating periods of academic study with co-op. So because of this, you cannot graduate on co-op. You have to graduate on an academic term. Your student loans remain in deferment. You can live in on-campus housing if you'd like, and you still have access to all of Northeastern student resources. So you still have access to the library, the gym, dining halls, any clubs you're associated with. All of that is still available to you on campus. So in a few moments, you're going to be hearing from a couple of MES students, Marine Environmental Science students, about their experience with co-op. If you have any questions at all or would like any more information about the co-op program, you can always contact me by email or phone. My contact information is up there. And yeah, I look forward to meeting all of you.
Thank you.
Oh, and I'm going to pass it back to Jeff Tressel now. Sorry about that.
No worries. Nice job. So Jen, I'm going to go through these next 3 slides fairly quickly because I'm looking at the chat and there's lots of great questions coming in from the students. I want to make sure we have sufficient time to answer them. So I think, one of the things that's just important for you all to remember, and some folks have asked about this in the questions, is about research opportunities or experiential learning. And I just have to say that that's at the core of all that we do. And in fact, our students can participate in research opportunities as soon as or as early as their freshman year. And not all universities provide that opportunity for freshmen. Our faculty are really active in trying to create and cultivate these opportunities for our students, because the best way to learn is by doing. And this is particularly true when you're dealing with scientific disciplines. We also really value global opportunities. Northeastern is an amazing or has an amazing global network that creates all kinds of opportunities around the world, whether it's an international co-op or doing a dialogue of civilizations. It really is amazing how extensive our network has become that allows you to engage in opportunities beyond the Boston campus. And at the end of the day, as a university, we're really committed to creating global citizens. Our model, our learning model is really based on integrating experience. And obviously an important part of your experience is a journey that you take. And while Boston is an outstanding place to be, it's one of the best cities in the world for people to pursue academic studies. We also really value and appreciate the importance of branching well beyond Boston. And as Emily mentioned, our co-ops cover all 7 continents, including one student or multiple students who have done co-ops with Bill Dietrich down in Antarctica. So Boston will always be your home. Boston's a world-class city for learning, but we think we've really added to that by building out our global network. So I think it'd be great to hear from some of the students. The first person that we're gonna hear from about her experiences is Tess, I believe. Right, Tess?
Yeah. So hi, everyone. My name is Tess, and I'm a 3rd year at Northeastern studying ecology and evolutionary biology with a minor in communication studies. And I want to first talk about the co-ops I've had the experience of doing at Northeastern. My first one was actually at the Northeastern Marine Science Center, which was talked about earlier. I was a part of the outreach team where I did literally everything. I took care of touching animals. I taught science curriculum to local elementary school students, and I helped host a 500-person virtual symposium. And through that experience, I learned the career path I want to do, which is environmental education, which is the crown jewel of co-op, which is discovering what you want to do. So after that first co-op, I got do a second co-op, which I'm actually currently in, which is at the MIT Energy Initiative. I'm a part of their education team where I'm learning more of the back-end admin work that goes into supporting undergraduate programming. So through that experience, I've actually really appreciated all the work that's gone into all these people today that you've heard from. And even though this co-op has been remote, Northeastern does a great job of making you feel a part of the community, and also every co-op in general does a great way of making you feel a part of the community. So don't be worried about remote co-ops. And the next thing I want to talk about, so my first 2 co-ops were in Boston, but I also got the chance to study abroad with actually Professor Duffy, who talked earlier about marine biology. The dialogue I went on was called Food, Forest, and Fisheries, and we spent the first 2 weeks in Romania studying applied conservation biology, where we were taken around the Fagras Mountains with a foundation who was building a national park in the Fagras Mountains. And as you can see by the pictures of the left, we just went everywhere. We hiked all the time and it was amazing. And then the next 2 weeks we spent in Greece studying food sustainability in the Mediterranean. Less about hiking, more about learning about the diet of the Mediterranean. And we really learned that the culture is really embraced in the diet. And through that experience, I learned a global view of the issues that Northeastern teaches you in your classes. And I loved that experience. Tara and me talk about it all the time, but I actually got to go on that experience after my first year, which was amazing. And all these experiences have taught me a great deal, and I feel greatly prepared for graduating in a year. And yeah, those are just some of the experiences you have.
Great, thank you, Tess. And I think next we hear from Alex, correct? Is that right? Yes, Alex.
Yeah. Hello, everybody. My name is Alex Anderson, and I'm a second-year MES student with minors in computer science and ecology. So this past semester, I've been on my co-op cycle working remotely for a biotech company. And we work on designing products centered around consumer-grade medical devices and environmental preservation solutions. So I work on a pretty wide range of products. It's a great team, too. And the senior engineers really took me under their wing. I think they're all pretty shocked and a little bit jealous that a college student, especially an undergrad, gets to do what I do on co-op. So also, I'm able to work fully remote. The co-op that I'm working with is from my home in Minnesota. And I'm actually living on campus in Boston. So I'm still able to get that campus feel and be with my friends who are mostly in classes. So at the beginning of the year, my academic plan had me on the fall co-op cycle, but I wasn't sure what the year would look like with COVID getting bad. So I opted to have one consistency in my schedule. And Northeastern was super flexible, and it was no problem for me to switch my co-op cycle. I was on a fall and I need to switch to the spring. So I'd be able to spend the spring semester on my co-op, as I had a pretty good option available to me. Yeah, and Northeastern let me switch the cycle around really quick. I'm a bit of a procrastinator, and I didn't get to switching the schedule around until a few weeks before the academic year had started back in September. So in order to be on co-op, you need to take the professional development class, which is basically a co-op professionality prep class. It's pretty great, and it really made me feel prepared for the work I'm doing now. And originally, this class was not on my schedule, but it was really easy to get it added. And then secondly, was I needed to actually create the co-op that I wanted to do. It was a self-made co-op. And it was super easy. I worked through the official NU work site, which is basically just the Northeastern co-op directory and function site. And it took less than an hour of form filling and only really required a few emails back and forth with my advisors and the people I was going to work with. Yeah, I really just appreciate how easy it was for me to make my own plans, and it wouldn't have been possible without the flexibility. Overall, yeah, and so kind of go over what's on this slide. This is basically 3D printing applications with unique materials. And you can see in the top left picture, it's a bunch of different materials. They're silicones, and they're all mixed differently, and they serve as different medical device materials. Super interesting. Yeah, and on the right, you can see it's the extruder printing one of those little test cylinders. We turn them into cylinders so we could test them with mechanical traits and just see how they would function. And yeah, overall, my co-op experience has been really great this semester, even regardless of all of the COVID going on. And speaking of some of my friends who are on the co-op like searching thing right now, they've only had positive things to say about the experience given the circumstances. Yeah, and even those who weren't able to get co-ops this semester for whatever reason, they really don't have any problems looking forwards, because they just did the opposite of me and swapped their co-op cycle for academic semester. Really, it's just, I was really blown away with how flexible everything was. And this is a great program in general. I'm so thankful for the opportunity to spend just time, when I'm young in college, like working for a professional company and learning the skills that I need to interact with this company. Northeastern, like I never didn't feel prepared. Yeah, I think that says a lot.
Great. Thank you so much, Alex. We really appreciate it. We have Allison and Jarila, I think, and we have 8 minutes left. Sorry, Allison and Jarila. I take responsibility for talking too much.
Don't worry, it's all good. Hey everyone, my name is Jarila. I'm a third-year marine biology student, and I'm one of the co-founders of the Marine and Environmental Science Peer Mentorship Program, better known as MESPM.
And I am Allison. I am one of the other co-founders of MESPM. I'm a fifth-year marine bio student. So our program aims to strengthen our department by creating stronger relationships among our students and really encourage the sharing of resources and opportunities among the undergraduates here.
And the core of our program is the creation of mentor and mentee pairs of undergraduates. So at the beginning of each semester, we take surveys of people who are interested in participating in the program, and then do our best to pair them with other students with similar interests, goals, and Northeastern experience. And by Northeastern experience, I mean, if you're an NUN student, we'll try to pair you with an upperclassman who was also an NUN student in order to give a mentor who can best understand their mentees' experiences. And our pairs consist of 1 or 2 mentors and 1 or 2 mentees, and are arranged so that mentees and mentors are from the same major.
We've also created an online platform for communication within our department. So student groups can post events, like we've got a marine bio club, we've got an environmental science club called the Terra Society, and they can post events that they'd like people to come to. And we also have a fantastic academic programs assistant who constantly updates this platform with opportunities for internships, scholarships, undergraduate research, basically anything you can think of. It's also a pretty great place to kind of seek out advice from fellow students about classes and professors.
Definitely. And we also host events designed to benefit the entire department in terms of social and professional development. In addition to our monthly meetings, which help undergrads in our department get to know each other, we host events like our graduate school panel, which you can see a flyer on our slide right here, which we held this past January. And these events are really designed to provide additional networking and career opportunities for our students. And we're really looking forward to hosting more events like this in person in future semesters once it's safe to do so.
So all combined, we really hope that these efforts are going to help our undergraduates feel more connected to the other students within their department and gain opportunities and network connections that'll help them succeed after graduation. We're both more than happy to answer any questions about the program or just Northeastern undergraduate experience. We're also both part of +1 program, so happy to answer things about that. And since we're running short on time, we'll leave our email addresses in the chat, and we are happy to hear from any of you.
Thanks so much, Allison and Jarila. And thanks to everyone for presenting and to all of you for listening. Hopefully you got a good sense of what we're all about. I suspect that in some ways it may be a little overwhelming, but please feel free to get in touch with us after this session if we can't answer all of your questions completely tonight. But hopefully you'll see that we're really a solutions-focused department that's really committed to giving you, the student, the kind of training that you need to thrive and succeed in your professional career. So hopefully you've learned enough about us to come join us. It's really a great department, and in addition to it being a great place academically, I think we really have a wonderful community that really embraces diversity and equity and justice and knowledge all together. So it's a really special place. I'm going to stop talking there so we can get some time for some questions. I see lots of questions coming in through the chat. So Lauren, do you want to coordinate
Yes.
that?
Absolutely. Thank you so much, Dr. Tressel, and thank you to all of you. This was really great information being shared. I would like to do kind of some quick 30 seconds or less questions, and I will start with Dr. Duffy, if you don't mind. There were several questions that came in. Do you have to be a marine biology student in order to participate in the 3Cs program?
Great question. You do not. So students can participate in the 3Cs program solely as an undergraduate, fit that into their curriculum. They don't have to be a marine and environmental science major. We basically ask for 3 required courses to go into the program. If you are interested in doing the +1, you can either be an environmental science and sustainability major, a ecology and evolutionary biology major, or a marine biology major in order to matriculate into the +1. So there are multiple ways to participate.
Excellent. Thanks so much for that. Dr. Bowen, I am going to ask you to answer a quick question. We had students who are wondering, what if they join one major and decide that they want to be in one of the other majors at a later point in time? How flexible is it to change your mind and try different things out?
That's a really great question. And the answer is that just as Alex described, there being a lot of flexibility with co-op, there's also a lot of flexibility with our curriculum. Our marine biology and ecology and evolutionary biology students take a lot of similar classes in their first 2 years. And so you could even wait until your 3rd year to decide which of those paths you want to take. And it wouldn't hold you back at all, because the core foundations of those classes are really similar. Similarly, we work with the biology department so that there's flexibility in moving from biology into ecology and evolutionary biology or the other direction. And our environmental science and environmental studies core curriculum has a lot of overlap early on in the curriculum too. So we're always really happy to help you work through finding exactly right where the best home is for you within our curriculum.
Excellent. Thanks so much. The next question I want to pose to Alex, if you don't mind. Alex, you were part of our NUWIN program, and there were several questions that had come in earlier in this session. Can you just tell us quickly about your experience in being able to start at a different location and then then coming to our Boston location in the spring, and how you felt if it prepared you for your curriculum?
Yeah, absolutely. I'd love to. So I was an NUWIN student. I went to Australia with the College of Science, and I loved it. It was just, more than anything, it was seriously just one of the best experiences of my life. You go with just such a select group of kids who are all academically brilliant, but they're also the kind of kids who, they want to be there. They want to be halfway across the world. And I really made, all my roommates who I'm living with now, except one, I made friends in Australia. And coming back, yeah, I was terrified. I was really nervous. I'm like, wow, Northeastern's a massive school. And we were with a group of really like 100 kids in Australia, all Northeastern students. I'm like, man, like, where am I going to, because I'm someone who's really into clubs, and I wanted to make sure I didn't kind of miss out on getting right with clubs. And especially just, being social and making new friends. And navigating around campus. But it was a really easy transition. A lot of it was because, I had such great friends from the NUWIN program, but also there's just so many resources that Northeastern offers. The academic speed was definitely different. It's something that I had to calibrate to. It was definitely a notch up coming back, but that was actually great because it really just set my standard higher for the rest of my time here. And when I did find myself like needing help adjusting, I was able to go and get help with the I forget the name of basically the peer tutoring program. And I only have good things to say about that. And there were a lot of like specific seminars and web events and on-campus events for all the NUWIN students. So when we came back, we still had the support group of the entire NUWIN program. I run into my program coordinators just on the streets in Boston. Like literally the other week ago, I ran into someone I knew. Like this just happens all the time. And yeah, it was daunting coming back, but it was a great transition. It was super easy.
Wonderful. Thank you so much for answering that question. And believe it or not, we have already filled the hour, and I want to be respectful of everyone's time. Therefore, unfortunately, we're going to have to wrap up this session, but there was so much incredible information that was provided. Thank you so much for all of our faculty members who have done department and major overviews, and of course to our amazing students, as well as Emily from our co-op department. I hope that everyone can see how truly inclusive this department is, and the majors and the different opportunities that are available for our students. And contact information has been shared. So if you have any further questions beyond this session's information provided, please do reach out to our faculty members to get your questions answered. And with that, I want to thank everyone in our audience this evening for staying with us. And we do hope to continue the conversation with you. So do reach out if you have any questions. Have a great evening, everyone. Thank you.
Thanks, everyone. See you soon.